So now, let's say, and this is theoretical, this is just let's imagine that you're producing only brine, okay? And you have been given the temperature and pressure conditions at each location of the flow line, the production line. And that's what we're going to do. We're going to see what happens when you change temperature and pressures and how the scaling risk changes as you change those temperature and pressure conditions. So the next object that we're going to learn in this hour is going to be the scale scenario, okay? So we are going to go to the actions pane and look for the scale scenario and double click on it. And now change the name to Olympus Production. Okay, this is going to be only imagining that you have produced the brine. And I just want to see what happens when you change temperature and pressures. So we are going to, so you'll see here in the inlets table, in the inlets tab, you have 3 different columns and you need to fill each one of them. So you will select here, you'll see that you have the option to select from whole fluid and brine. We will select the brine. And the software immediately recognizes that we have created one brine named Olympus Brine that has been created in the MSC SRK framework. We select it, and then we need to define the flow, the produced brine flow. That was measured at the separator. It was 200 cubic meters per day. Okay. The red button, you see still a red button, so it means that there are some warnings. We have not completed this yet. The reason why is because now we need to go to the conditions tab. And in this conditions tab is where you're going to enter every single location of the production line and then put the temperature and the pressure for each location. So we are going to start putting, there are going to be 2, 4, 6, 7 different locations. So we are going to enter every single one of these locations with the respective temperature and pressure. So for location, go to the drop-down arrow here and now look for the first location will be reservoir. And temperature will be, make sure that you have degrees C and bar. But if we did the first step, everyone should have the same units. So it's 125 degrees C and 275 bar. Okay. The next one will be bottom hole, and you have 125 and a decrease in pressure of 15 bar there. The third option is downhole, and then we enter here it's 115 and 190 bar. Our fourth one is midwell. So notice that in the bottom, you start seeing like a flow process where you start seeing that from the reservoir to the midwell, there is mass transfer, and you're not losing any mass. The mass is being conserved. Okay. Well, let me see. Midwell, I cannot talk and do the same thing, enter the information at the same time. 100 and 100, and we have 2 more locations. Choke. And we have, that is 90 and 80. And my final location is going to be my separator. So my separator has 60 degrees C and 30 bar. We double check 125, 125, 115, 105, 90, 60, 275, 260, 190, 130, 180, and 30. Okay, perfect. So we have created these locations and we have added temperature and pressure. Also, you'll see a fourth column here that says drop solid. Again, if I want to quantify the maximum scaling risk, I do not use this option here, drop solids. You could, if you know, for example, if you're producing, I don't know, halite, you know that the kinetics of that mineral is super fast, and you know that you're seeing, or you have, maybe the production engineer knows that you are producing a lot of halite at reservoir or at the bottom hole, so you can drop the solids, okay? And probably that will help you match what you're seeing at the separator. But if you are talking about calcite or barite, I generally don't like to use or to select drop solids because those solids take longer time to form. And drilling here, we cannot account for the kinetics. The software is only allowing you to understand the thermodynamic point of view, but not the kinetics. But you have that option in case you definitely know that you're dropping some type of solids. And I've done this only when I know that halite is being formed at certain locations in the production line. Okay, so these are the locations, and the last step here is to go to the solid tab. So in here again, remember, we put in the brine, we did not allow any solids to precipitate. Okay, we just said, no, I'm going to bring all that digested sample, and I am going to put it into this production. Okay. Now, in here, for this production, I do turn on solids, and I will select the option standard solids. So anything that is super saturated, I will let to precipitate out. Okay, it will precipitate out because I am turning on these solids, and if calcite is super saturated, the software will calculate how much of that calcite is precipitating at each one of these locations. Okay, notice that you have 3 different sections here for solids. You have the standard section, or the standard category, and this category just basically is giving you a list of the standard oil and gas scales that can form. And these solids will depend on the what you enter in the brine analysis. So, for example, you in here don't see siderite. Siderite is something that you would probably see as a solid as a standard oil and gas solid, or a standard oil and gas scale. But since we don't have iron in the brine analysis, you will not see it here. Then there is another option here, it's called the expanded solids. And this expanded list is when you may have unique compositions. Let's say you're doing completion fluids, so you will use calcium chloride, for example, or you're doing a flooding applications, and maybe you are using magnesium hydroxide. Maybe you are doing a steam flooding, and then you know that you're increasing the temperature and you will be dissolving some quartz. So then you will have probably the potential to form silica scale. So you can select it from here. Okay, that will be the expanded. To see the solids, just make sure that you click on the standard, so that I see a question in the chat. Just make sure that you have selected the standard solids there.
Yeah, it doesn't give me that option. It just says solid selection, and then a dialog box that says all.
You don't see these 3 options? Is that what you're saying?
No, I just see all.
Interesting. Did you scroll up and down? I don't know what it could be. Yeah, sometimes if you scroll up and down, it appears. Okay, so just save that file and maybe just click on a different tab and see if that maybe puts it back to normal. I don't know what could be causing that. Do you have in the Olympus production, do you have the solid button enable?
Yes, that is, and it says solids that are allowed to precipitate down at the bottom, but yeah, it just doesn't give me a list. It says all, and then if I click on the plus symbol, it gives me H2O. That's it. That's the only.
Did you bring the brine in? Let's go back to the inlets.
I did, but okay, there we go.
Okay. Yeah, maybe it's not identifying the brine, and when it doesn't know the brine, it doesn't know which components you have, and if it doesn't know which components it has, so it will assume that you just have water.
Yep, we're good. Thank you.
No problem. Okay. So for all, this is the last section for the solids, the all category. And basically in here, you will see every solid that is present in the OLI database, and that obviously matches what you have entered in this brine composition. So if you don't find anything in your expanded or in the standard, you can always go to the all solids, and then in here you will see all the possible combinations and all the possible solids that you will have for this specific production. Okay, so that was about the solids, but in the standard practices to select the standard oil and gas solids, and you'll see that when you selected the standard, now there are no warnings, everything is perfect, and then you go ahead and calculate.
Dana, just a quick one.
Right.
In conditions, say you've added one condition too many, how would you remove that from the calculation?
What I would do is I selected, you see how I have this arrow here? So yeah. I will select it like this and click on the delete button, or not click, hit the delete button in the keyboard.
I'll try that now.
Let me know if you can delete them.
Yeah, it worked. Thanks.
Perfect. Okay. So we went through 3 tabs, and the final step here is to understand the results, right? What is this specific calculation telling you? Okay, so we're going to go to the plot tab. And this plot tab is the dominant prescaling tendency versus locations. So you see dominant prescaling tendencies versus the different locations, okay? The software, this is the default table or the default plot for every scale chem calculation, okay? Every time that you do something, this will be the default. And what do we mean by dominant prescaling tendencies? What we mean by dominant prescaling tendencies is that we are plotting the 5 minerals that have the highest prescaling values. And they are selected and they are put in this plot, okay, at each location. So this plot is telling us that there are 5 solids. These are the 5 minerals that have the higher prescaling tendencies. And it's telling us that calcite is the one that has the highest prescaling tendency values. And this is that everything that is above 1 is supersaturated. So we have 3 supersaturated solids. We have calcite, we have aragonite, and we have strontianite. Probably barite as well. Yes.
One question: is water a prescaling like mineral?
It will be ice.
Ice. Oh, okay.
That's a good question.
Thank you.
So in this case, even barite, at some point it starts like undersaturated, and you start seeing that maybe a choke is 1.51. So it starts getting super saturated. So these are the potential solids that could form, but that doesn't mean that they will form, right? So what we need to actually see from this plot, more than just the prescaling tendency. The prescaling tendency values are important because it will give us the driving force of precipitation to occur. But it's important to know how much of these solids will form. So this plot is the default plot. Now, what I want to show you is how you can modify it so that you can see the amount of solids that have precipitated out. Because we have turned the solids on for the production, okay? So what we are going to do is in the right upper corner, there is this option or this button that says variables. We are going to click on it. And this will open a new window, okay? And in this window, what you're going to see here is all the possible variables that you can plot, all of them. And even if you expand this, every single category, you have more variables and a lot of things to select from. I am interested to know which solids have precipitated out. So I'll select solid. I expand that category, and the software has calculated or has predicted that 2 solids precipitate out, barite and calcite. Okay, so we'll select these 2. I'm going to put them, you'll see that the software says in the x-axis we have locations, in the y1 axis I have the dominant prescaling tendencies. I want to use the y2 axis. So I will put these variables in the y2 axis. So I click on this barium sulfide or the barite and use this right arrow here, or this arrow here for the y2 axis to put my barite under that y2 axis. So I'll do the same for calcite, and there it goes. Now, I know that all of these are dominant prescaling tendencies, but now the software is telling me that really it's 2 solids that I am precipitating out. So I can modify this. I don't want all those prescaling tendencies. I can go and say, go to the prescaling tendencies and say, you know what, I don't want the dominant. I double click on it to remove it. I only want the calcite. So you can double click on it to put in the y1 axis. And I want the barite. You can also use the right arrow here. So we have these 2. We'll compare. We'll have now two things that we want to see: the prescaling tendencies and the amount of solids that have precipitated out. So then we click OK, and these are the results. Okay. So again, this will actually even like this is kind of it's too much information. So maybe I can show you the table. Now we have this, okay? Then rather than plot, I want to go and see view data. So let's click on the view data in the right hand upper corner, view data. And in here, you can see the tabulated data. Okay. So what is happening? So again, prescaling tendencies, this is definitely for calcite. We are having supersaturated values. And these are the amounts of solids that will drop out at each location. The maximum amount, let's see, would be at bottom hole conditions. So we are having such maybe a pressure drop that is significant that maybe just causes this much of precipitation at that point, at that location. When it comes to barite, so we'll see here that initially it's undersaturated. And at some point from the mid-well up to the separator, we are starting to see some barite that is precipitating out. Okay, and at the saturated value, at the saturator location here, not saturator, the separator location, then we have 5.4 milligrams per liter that are precipitating out. Okay, and we are only having at that location a 2. Is the solution or the barite is 2.8 times saturated. So the combination of these prescaling tendency values and the mass predicted to form or the mass predicted to precipitate out, these values are the ones that are used by chemical suppliers or by the operators because it will help them to quantify the risk, or at least to create a qualification of the mineral risk, right? So you may have this information, And then you will need to decide the scale inhibitor that would be best and to use here, and which will be the concentration that you need to use for that scale inhibitor. Unfortunately, OLI doesn't do this part about the inhibitor. We don't give an inhibitor recommendation. We don't have inhibitors in the data bank. However, this is an announcement, and we are working on this. We are working on adding some scaling inhibitors, or for in our data banks, and it's still under development. I cannot even tell you when will be the release of that, but I know that we are on the works to add at least the most common inhibitors, and we can tell you how much, based on these results, how much of the inhibitor you can add to reduce the scaling tendencies.
Dan, can you just go back to the how you switch the plots? Eliminate. You went to variables and you select. I missed that part. Sorry.
Sure, no problem. Yes, you go to variables.
Okay.
So I had the dominant pre-scaling tendencies here.
Yeah.
So I go to the pre-scaling tendency values.
Okay.
But I deleted it. I didn't want it. So I double click on the dominant and it put it back to what it was.
Okay.
And what I did is I simply selected the pre-scaling tendency values for my calcite and my barite, because that's what the software calculated that will precipitate out.
Okay, thank you.
Okay, so let's say, let's click on view plot again. This is the plot. And let's say this is a plot that we will always study. We don't want to recreate it anymore. Too much clicking. So the software has an option. It's called the plot template manager to the left. Let's see here. And in here, you can save this type of plots, the variables that you are using for these plots. So we're going to save this plot. And to do that, we go here for the plot template manager and click on this white box area that you see here. And we're going to say that this is, I don't know, pre-scaling and solid table. No, plot. And then we simply click on save, the save button. And you see, I have saved it here. So now if I want to go back to the default plot, I click on that and it will show me the default plot. And if I want to go back to my pre-scaling and solids plot, I just hover over it, or I just click on it and it will.
Dan, I managed to have lost my actions window on my plot template manager while I was trying to mirror your actions. Then how do we get them back?
Yeah, what you're going to do is you go to view, oops, and minimize this, view, toolbars, and then you'll search for the plot template manager. Make sure that is selected.
It's there, but it's okay. It's not. I've expanded it now. So how do I get those options up in the box? Just click on default plot.
So you already have your pre-scale and solid plot, right? So you are in here. Do you have this plot?
No, I just have default plot in my plot template manager.
Okay, you only have that. So what you will need to do is to go to variables and make sure that you select the pre-scaling tendency values for calcite and barite and the solid amounts for calcite and barite in the Y2 axis. You need to do this step first. So I'll wait for you. You can go to variables. Pre-scaling tendencies.
Pre-scaling index I was in then on. Sorry.
You may have here dominant pre-scale tendency, so just double click on it to delete it.
And then into Y2 axis. How do you get this Y2 axis?
Oh, it comes there in this by default.
Okay.
So what you need to do is to use the buttons down here to put those variables in the Y2 axis. The double clicking works only for the Y1 axis, but for the Y2 axis it doesn't. So you need to use these buttons down here.
I know, but I lost barite. on the left-hand side. I no longer see barite like you, because you put it, how do you, where's barite now on the pre-scaling tendency? There's no barite in here because you moved it to the right.
Correct.
And
Yeah,
calcite.
it will remove it. Yeah.
So how do I add on the Y2 axis? How do I add barite and calcite on the Y2 axis?
So the Y1 axis is the pre-scaling, okay? For
Okay.
the Y2 axis, we want to plot the solids. So you scroll down,
Oh,
solids, and there must be two solids, the barite and the calcite.
hold on a sec. Where are the solids? Scaling index.
You scroll down, so you have pre-scaling, you have pre-scaling index, scaling, blah, 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 liquid, vapor, liquid 2, solid. Expand it and select the cal. So it should be, you should see it like this.
Okay.
And you
Put it in the Y2 axis.
and put it here. And then OK or apply to see the changes. And then OK. And also, I forgot who was having the question. So now you should have this plot. Okay. Now that you have that plot, for the person that was asking me about this.
I don't have that plot.
Yes. And now you go to the template manager and you'll see down here there is a box.
I don't have that plot. My plot shows the CaCO3 pre-scaling tendency from 0 to 1.1. Doesn't even show the barite anymore. I mean, it looks, the calcium pre-scaling tendency and barium pre-scaling tendency, the scale is not from 0 to 16, but it's between -0.2 to 1.2.
That means that you're probably using the scaling index, not the pre-scaling tendency.
Scaling tendency.
Yeah, make sure that you don't use the index. No, not index. You want the pre-scaling tendency.
What's the difference?
The difference is when I was explaining before, one is the logarithm 10 of the scaling tendency.
Okay.
So the index is the logarithm 10, and the pre-scaling tendency is not the logarithm 10. It's the ratio.
Okay. And so the units on the left-hand side are just the ratio K over Q, or the product over equilibrium constant.
Yeah, that's right. So you're probably using the scaling index. Okay, so then you save the plot. Then you go here to the plot template manager. Doesn't matter I just want to show the utility. In here, so you would come to the plot template manager, and in the white box, you give it a name. I had given the name pre-scaling and solids plot, and then I click on save, and that plot is created. So whenever you want to see the default plot, you can click on the default plot, or you can go to the pre-scaling and solid plot. Okay. I hope that now you could get that plot.
Yeah.
Perfect.
I already saved the wrong version, so now I have to give it a different name.
Right. Yeah, you can play with that. It's just to show the options that you have in the software specifically for the plot template manager. Okay. So that we will have more opportunities to play with this. But let's continue with the next object. Probably we will spend 10 minutes doing the next object because, we have to, there are a lot of objects in this software, so I want to cover as many as possible. Okay,